looking at number 7 here, we have a question. A mass of 1.250 grams of benzoic acid was completely combusted in a bomb calorimeter. If the heat capacity of the calorimeter was 10.134 kilojoules per Kelvin, and the heat of combustion of benzoic acid is negative 3,000 kilojoules per mole, calculate to 3 decimal places the temperature increase that would have occurred in the apparatus. All right, on this type of problem here, what we want to do is figure out how much heat was produced by the benzoic acid. Now we know that's where all the heat came from because we're talking about taking that mass and burning it. And that is going to be something in joules or kilojoules. And then once that heat was made, it was transferred to the calorimeter. Now, this would have given off the heat, this would have absorbed it, so they are going to be opposite signs. Now, how we go about getting the Q's is a little bit different for these two. So for the benzoic acid, what we're going to do is take that 1.250 grams, and we want to turn it into moles. So we're going to have to get the molecular weight of the benzoic acid. And let's see, C7, 12.01 times 7 plus 6 times 1.008 plus 2 times 16 gives me a molecular weight of 122.12. Now the reason I needed to convert that into moles is because the bomb calorimeter, or the heat of combustion, is always listed in moles, or at least it is in this case. So I'm going to put that 3226 kilojoules per mole. Now all these units would cancel out. We're going to see that this is going to give us our heat for the benzoic acid in kilojoules. Alright, to figure out the bomb calorimeter one, now a lot of times on Q's I give you a specific heat capacity which also has a mass in it. The reason we don't have that with a bomb calorimeter is because it's a rigid device. It's a very fixed mass. So they always have a heat capacity stamped right on the container. So we just have that popping up here for our heat capacity. Now technically what this is going to be multiplied by to get the actual Q would be the change of temperature goes for. But in this case we're going to solve for that delta T. Alright, so to do this whole math, we are going to take that 1.2, was that 1.20? 1.250. We're going to divide it by the molecular weight and multiply that by the 3,226. Now I'm ignoring the negative because I'm going to ignore it over here. So I just let them both cancel each other out. Alright, so that is our kilojoules coming out from burning of the benzoic acid. And now we're just going to bring this over to the other side. So divide by 10.134. And we get that the temperature increase is only 3 degrees, but I have 4 significant figures, so 3.258. Now, the units are either degrees Celsius or Kelvin, and they can be interchangeable because this is a delta T. This is how much it changed. And what we're saying is if we burnt that much, this bomb calorimeter should go up by 3.258 degrees Celsius or 3.258 degrees Kelvin. But both those units are technically interchangeable because this is an increase and those degrees are both the same size.